Hi, in this demo we'll take a look at the task framework and see how we can use it to run services asynchronously and in parallel. So let's start by adding a database because the task framework uses a database. And let's switch to the repository. Let's create a services folder. It will create a service that will be slow. So let's call it a slow service. And we're going to assume that this service is doing like a lot of computation or whatever, something we want to do in parallel. For now, let's just sleep. We'll sleep for 1 second. And after that second, we'll do a server log notifying that everything's okay. Maybe we'll add an input message that we also output so we know which one it is. If we now run it, you can see it took approximately 1 second. As you can see, we have the server log here. Everything is okay with our message. Let's now build a new service. Let's call it multiple slow services because you want to call this one in a loop. So let's add a for loop and let's just say for 5. Let's call this one. Let's actually inject this as the value and then we'll just map that as the message. If you do nothing special, we would assume that this one will take 5 seconds, so 5 times the slow one, and every second or so it should output a message here. So let's do that. And indeed, approximately 5 seconds, and we had the messages come in here. So it's working as expected. And what we want to do now is we want to use the task framework to do this in parallel. So let's take this invocation and let's switch to target. So in the target dropdown, we can actually choose where and how we want to run the service. By default, obviously, it will run as you would expect it to run, but you can also offload it to somewhere else. For example, let's take the task framework. So at this point, we'll actually be saying to the task framework, you do this execute. Then we can start to fill in a lot of configuration. We can add arbitrary metadata to annotate our task for later lookup. We can do run at, which lets us indicate when we actually want to run it. For example, let's run it at midnight. We can use the data store. For example, interesting if we have large data. We can annotate it with some metadata that is very fast to look up. For example, group ID, context ID. We have a correlation ID as well. Apart from that, we can do a task target. So we can indicate who should run it. By default, it will be any, but we can leave this open. It will be this by default. But we can also set, for example, target cluster. We could say maybe the computation cluster should take care of this. Let's leave this open. We can do a run in. So instead of a run at where we say run it at midnight, we can say run it in 2 hours. We can play with transactions. So the entire task framework is transactional. It has default transaction handling, or you can make it part of your own transaction if you want to make it part of a bigger whole. This allows you to, for example, submit 1,000 tasks and have an all or nothing whether or not those tasks should actually proceed. We also have a schedule. So apart from specifying a specific date and time, we could specify a schedule and the next available slot in that schedule will be used. And we can indicate a queue. The queue is an interesting bit. If we leave it open, an anonymous queue will be created, which you can only publish on for the duration of the root service. If we use a named queue, we can actually target one of the existing queues and reuse the queue across multiple services. Let's leave it empty for now. Let's now run this. As you can see, we get an immediate result back. But if you look at the server log, it is still being run. By default, the queues are created as sequential, which is why there's still a 1 second interval. These tasks are being executed sequentially, but we can also make them concurrent. But let's first have a look at what this task look like. Let's add an application. Let's already load the application. Let's add a user. Let's log into the application. And now that we're here, let's update the skeleton and let's quickly add a top menu. And then we go back here and we add the templates for task framework. Let's go to the task queues. We have our page here. We can see that a queue has been created for our slow services. It's anonymous. It's finished and it's published, so basically this queue is entirely closed. If we click on the queue, you can see that we have all the tasks here, and the concurrency is currently 0. Let's create a new queue. Let's call that test, for example. Let's add a concurrency of 5, and let's do it like this. So now we have this queue. Let's go back to our services here, and we can actually take this one and just use queue test. Let's do it again. And as you can see, the logs are now printed out of order because there's 5 threads picking up tasks at the very same time. If you go back to our application and we select this queue, you can see that all of these have been executed. By clicking on a particular task, we can see the properties and the logs. This is simply an introduction into the task framework. There's a lot of other topics that we might cover. For example, for anonymous queues, you can easily add staged tasks that trigger once the queue has been fully processed, allowing for batch processes with a final action at the end. We can configure schedules to automatically create tasks at given times. We can create templates for queue configuration, so new queues are automatically created according to a specific template. We can configure transient error processing rules where tasks will be automatically retried according to specific rules and schedules and stuff like that. But this should be enough to give you a feel for how the task framework is incorporated into blocks. I hope it was interesting. See you next time.